Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello future engineers, subscribers, viewers, and students. Here are another set of problems in algebra, particularly in coordinates and graphs. And this time we have to apply the distance formula and the division of a line segment principles in solving the set of problems here. Allow me to reduce animation procedure so that the capacity or the memory uh, consumption of this video will be short, and so that I can present few problems in just a short while. So here is the first problem. Prove that the points A, quantity -7, 2, B, 3, -4, and C, 1, 4 are vertices of an isosceles triangle. Also determine the area and the equal angles. So let's sketch the graph of the problem. So here is the graph, and we have points A, B, and C. A is at -7, 2 as shown. B is at 3, -4, which is plotted correctly. And C is at 1, 4, also plotted correctly. So for the area, one technique is the enclosure of this triangular region by this rectangular region. And the dimensions of the rectangle would be, for this, because this is the extreme right point, 3 minus right x, which is 3 minus left x, -7. That's why it's 10. Another way, you just count the number of squares on these sides. Then you can have the dimension 10. For the vertical dimension, it is upper y, which is 4, minus lower y, -4, so that's why it's 8. Another technique is you just count the number of squares. And for the other right triangles, such as this, we have right x1 minus left x -2, that's why we have 8. Upper y4 minus lower y2, that's why it's 2 here. For this right triangle, the dimensions, so 10, then upper y2 minus lower y -4, that's why we have 6. And finally, for this right triangle, upper y4 4 minus lower y -4, 4 minus -4, so 8. That's already finished. So right x 3 minus left x 1, so 3 minus 1 is 2 units. So from there, you can compute the area as 8, 10 times 8, 80, minus 1/2 of 8 times 2, which is 8. 80 minus 8, 72. 1/2 of 10 times 6, so 30. 72 minus 30 is 42. Then minus 1/2 of 2 times 8, 42 minus 8 is 34. So the area is 34 square units. Then, to show that these are vertices of an isosceles triangle, we compute this distance of AC as square root of 8 square, because we already computed the dimensions, 8 square plus 2 square by Pythagoras theorem, and it is equal to 2 square root of 17. Likewise, based on the figure, this should be the line segment that is supposedly equal to this side, and let's prove it. Square root of 2 square plus 8 square is also 2 square root of 17. So therefore, these vertices are vertices of an isosceles triangle. So that's the proof. Then for the area, I already computed and mentioned that it is 34 square units. Another way of computing the area is, by the way, AB is square root of 3 minus negative 7 AB. Sorry, this one. This is the midpoint of AB. So this is 1/2 of negative 7 plus 3. 1/2 of quantity negative 7 plus 3 is negative 2. And 1/2 of 2 plus negative 4 is negative 1. That's why that's at negative 2 comma negative 1. Then length of AB, this one, AB is square root of 10 square plus 6 square. 10 square plus 6 square, so 2 square root of 34. So the area for triangle, so this is the proof that vertices ABC are vertices of an isosceles triangle, because we have shown that AC, which is 2 square root of 17 units, is equal to BC, which is also 2 square root of 17 units. So that's why triangle ABC is isosceles. For the area, it is 1/2 of length of AB, which is 2 square root of 34. Then the length of CD is square root of 1 minus negative 2. So that's why we have 3 square. Plus 4 minus negative 1. 4 minus negative 1 is 5. So plus 5 square. And it is equal to square root of 34. So the area of triangle ABC, another calculations, is 1/2 base times height. So 1/2 of 2 square root of 34 times height, square root of 34. That's why it is 34 square units. And as I said, as mentioned in the first part of the video, I mentioned that the area is 34 square units based on the area of the circumscribing rectangle, and we subtracted the areas of these right triangles. Then for the angles, this is inverse tangent. So use your calculator because this is calculator aided. Inverse tangent of 2/8, the slope of this side is, that's 14.04 degrees, while inverse tangent of 6/10, which is equal to that, which is also equal to this angle, it is inverse tangent of 6/10 or 0.6 is 30.96 degrees. Therefore, 14.04 plus 30.96 degrees is 45 degrees. That's angle A. Then for angle B, this is inverse tangent of 2/8. Inverse tangent of 2/8 is 14.04 degrees. We already calculated this as 30.96 degrees. Therefore, the vertex angle B is 90 degrees minus 30.96 degrees minus 14.04 degrees. So A equals B equals 45 degrees. So we also conclude that this isosceles triangle is also an isosceles right triangle. So the area is 1/2 of 2 square root of 17 times 2 square root of 17. And that is also 34 square units. We proceed to problem 25. By using the distance formula, prove that the points A, negative 3, 2, B, 1, negative 2, and C, 9, negative 10 lie on a line. Also find the ratio of the lengths AB to BC and the ratio of the lengths AB to AC. So let's plot the points A, negative 3, 2, B, 1, negative 2, and C, 9, negative 10. So from the figure, it appears that the 3 points lie in a straight line, but we have to prove it by the distance formula. So the length of AB is, by Pythagoras theorem, 1, right x, 1 minus negative 3, so that's 1 plus 3 quantity square, then plus y2, negative 2 minus y1, positive 2. So negative 2 minus 2 quantity square. So 4 square plus 4 square is 4 square root of 2 units. That's the length of AB. Likewise, BC is equal to square root of right x 9 minus left x 1. So quantity 9 minus 1 square plus lower y negative 10 minus upper y negative 2. So that's negative 10 minus negative 2. So negative 10 plus 2 quantity square. So 8 square. This is 8 square. Therefore, BC is 8 square root of 2. Then the length of AC is square root of 9 minus negative 3. So that's 12 square plus quantity negative 10 minus 2 quantity square. That's also 12 square. 12 square plus 12 square is 12 square root of 2 units. Since AB plus BC, which is 4 square root of 2 plus 8 square root of 2, that's 12 square root of 2, is equal to AC, which is 12 square root of 2 units. So we conclude that points A, B, and C lie on a straight lines. So 12 square root of 2 equals 12 square root of 2, and this is the conclusion. Then for the question, ratio of lengths AB to BC, since we calculated the length of AB, which is 4 square root of 2, and BC 8 square root of 2, cancel square root of 2, 4 over 8 is 1/2. So the ratio of AB to BC is 1/2. Another calculation, we also obtain it as the ratio of the X projection of the length. So for AB, it's 1 minus negative 3, so that's 4, 1 plus 3. For BC, that's 9 minus 1, that's 8. So 4 over 8 is 1/2. That's why AB over BC is 1/2. Then for another solution, for ratio of AB to AC rather, AB is 4 square root of 2 units, while AC is 12 square root of 2 square root of 2 units, cancel square root of 2, 4 over 12 is 1/3. So AB over AC is 1/3. Then another solution, this time we use the vertical projection because we already used the horizontal projection. You can also use horizontal projection and show that it is the ratio of AB to AC is really 1/3. So for the vertical projection, it is negative 2 minus 2 for AB, while for BC, it's negative 10 minus negative 2. For AC, it's negative 10 minus 2. So negative 2 minus 2 over negative 10 minus negative 2, that's negative 4 over negative 12, and that's 4 over 12, that's 1/3 also. So that's it for this part. We proceed to the next problem. So problem 26, the abscissa of a point is negative 6 and its distance from the point 1, 3 is square root of 74 units. Find the ordinate of the point, or find the y coordinate of the point. So let's denote the other point as negative 6, y. We are looking for y. That's the other point. But then by distance formula, negative 6 minus 1 quantity square plus quantity y minus 3 square is equal to distance square root of 74 square. So this is negative 7 square, which is 49. Then plus quantity y minus 3 square equals 74. 74 minus 49 is 25. So y minus 3 quantity square equals 25. By extracting the square roots, y minus 3 is plus minus 5. If we consider positive 5, so 5 plus 3 is 8. Y is 8. Then if we use negative 5 plus 3 is negative 2. So there are two possible values of y, and these are 8 and negative 2. Then that's problem 26. For problem 27, if a is at negative 1, 2 and b is at 7, 8, find a point that is 3/4 of the way from a to b. Then that's problem 28, also by division of a line segment. So we'll focus first on problem 27, and let's have the point plotting. A negative 1, 2 and B 7, 8. So D is 3/4 of the way from A to B. So one solution would be we locate M. M is the midpoint of A and B. So therefore, because AD is 3/4 of AB, D should be the midpoint of M and B. So this is the condition. AD is 3/4 of AB. So D is the midpoint of MB. Then by midpoint formula, let's have the coordinates of M first, the midpoint between A and B. So this is 1/2 of quantity negative 1 plus 7, comma 1/2 of quantity 2 plus 8. So this is it. So 1/2 of quantity negative 1 plus 7 is 3, and 1/2 of quantity 2 plus 8, which is 10 over 5, is 10 over 2, which is 5. So M is at 3, 5. Since by analysis D is the midpoint between M and B, so XD is 1/2 of quantity X coordinate of M, which is 3, plus X coordinate of B, which is 7, comma 1/2 of quantity Y coordinate of M, which is 5, plus Y coordinate of B, which is 8. So therefore, this is 5, and this is 13 over 2. So point D, therefore, is at 5, 13 halves. So that's the answer. Then for the second solution, we have to consider the X coordinates ratio of the horizontal projection. So XD minus negative 1, that's horizontal projection of AD. You can also use vertical projection of AD for YD later. So XD minus negative 1 as to 7 minus negative 1 equals 3/4. So XD plus 1 over 8 equals 3/4. 3/4 times 8 is 6. Then 6 minus 1, because this is positive 1. So 6 minus 1 is 5. So XD is 5. Likewise, YD minus 2 as to 8 minus 2 equals 3/4. So this is 6. 3/4 of 6 is 9 halves, or 4.5. So 9 halves plus 2 is 13 halves. So that's why point D is indeed at 5, 13 halves. Then finally, problem 28. If A is at 1, 5 and B is at 9, 11, find a point that is 7/8 of the way from A to B. So let's have two solutions to be presented, just like problem 27. So we divide the line segment into 8 equal parts and show that M is the midpoint between A and B. So if M is the midpoint between A and B, then M1 is the midpoint between M and B. Finally, after we find the coordinates of M1, D, which is 7 parts from A, then there are 8 parts. D is the midpoint of M1 and B. So this is the first solution. D is the midpoint of M1 and B. M1 is the midpoint between M and B. And finally, M is the midpoint of A and B. So let's find M first. Let's begin with this, then next this one, then this is the final for the first solution. So M is 1/2 of 1 plus 9, 1/2 of 5 plus 11. So that would be 5, 8. Then M1 is midpoint of between M and B. So M1 is 1/2 of 5 plus 9. Then comma 1/2 of 8 plus 11. So therefore M1 is at 7, 19/2. Then finally D is the midpoint between M1 and B. So XD is 1/2 of 7, quantity 7 plus 9. 1/2 of 7 plus 9, comma 1/2 of 19/2 plus 11. So simplifying, 16 over 2 is 8, and 19/2 plus 11, that's 22 plus 19, 41 over 2. 1/2 of 41 over 2 is 41 over 4. So our answer for D, it is 8, 41 over 4. Then for the second solution, based on the ratio of length of AD to AB, which is 7 over 8, that's also the ratio of the corresponding horizontal, the ratio of their corresponding horizontal and vertical projections. For the horizontal projection, XD minus 1 as to 9 minus 1 equals 7 over 8. So this is 8 times 7 over 8, which is 7. Then plus 1 is XD minus 1 is 7. So X sub D is 8. Then for Y, YD minus 5 as to 11 minus 5. So YD minus 5 over 11 minus 5 is 7 over 8. So this is 6 times 7 over 8, which can be reduced to 3 times 7 over 4. 3 times 7 over 4 is 21 over 4. So YD minus 5 is equal to 21 over 4. Then finally, 21 over 4 plus 5 is 21 plus 4 times 5, 20. So 41 over 4. So YD is 41 over 4. So point D is indeed at 8, 41 over 4. So that's it for this video. I hope that you were able to follow the explanations and the solutions to these problems, those solved in 2 ways for some problems. And I hope that your knowledge in mathematics is increased, thereby preparing you for the challenges ahead.